Hey folks, welcome back to Anish Learns to Code. Today we will solve question number 1 on LeetCode 2-sum. In this video we will first discuss the problem, the algorithm or the solution. Then we will code the solution in Python. I will also add these links in the description and on the timeline below so you can skip to any section which you want. Let's get started. So this is the problem 2-sum on LeetCode. What this problem states is that we are given an array integers and we have to find an integer target and return the indices of two numbers such that they add to target. So what we are given in this problem is this. Let me just have a look. So let us say that we will be given an array. So for example, the array can be 1, 2 and 3 with the target value of, let us say, 3. So we can see that there are two numbers 1 and 2 whose sum adds up to 3. So we need to return the indices of these two numbers. So the indices are 0, 1, 2. So we need to return the indices 0, 1 for these two numbers whose sum is equal to target. We are also given some constraints in this problem. So let's have a look at the constraints. You may assume that each input would have exactly one solution. So for every array that we get, there will be exactly two numbers, exactly one pair whose sum will equal to target. So multiple pairs do not exist in the array whose sum is equal to target. We even have an example given over here. So we have 2, 7, 11, 15 and target is 9. So we can clearly see that 2 plus 7 is equal to 9. So the indices are 0 and 1, which should be the answer. Another example that we have is 3 to 4 with target 6. So 2 plus 4 is equal to 6, but 3 plus 3 is also equal to 6. So now this is something that we should see. You can return and you may not use the same element twice. So for example, let's say that we have this element 3 in our array. We cannot do 3 plus 3 equals 6 and then just simply return indices 0, 0. Whatever elements that we are using, they have to be unique elements at different indices. We cannot use the same element at the same index twice. It is possible that we have duplicate elements. For example, we have an array 2, 2, 2 with indices 0, 1, 2 and let's say the target value 4. So we can do index number 0, index number 1 such that 2 plus 2 is equal to 4. Having said that, this array, we will not receive this array because there are multiple correct answers in this array. But the problem on LeetCode clearly states that whatever array we receive will have exactly one solution. So this will actually not be a sample input. A sample input that we can receive is this 2, 2, 5 with target value 4. So now we can clearly see that 2 plus 2, index number 0, index number 1 will equal 4. So now let's discuss the solution. We can approach this problem from many solutions. The most naive, brute force way of solving this problem will be to compare pairwise every element. If there are n elements in the array, then the number of pairs is nc2, which is equal to n minus 1 by 2 pairs. So these are the total number of distinct pairs that we can take. So we can take every two elements in the array and compare them pairwise, add them and see whether we get the target value or not. If we get the target value, we can return their indices. So the space complexity for this will be constant. So the space my pen has hanged. Excellent. The space complexity for the brute force method will be constant and the time complexity will be big O of n square because we are comparing pairwise elements. So this is the most naive solution. This is not the best solution. Now the next best solution that we can think about is we can take this array and we can sort it. So let us say that we had this input array 2, 1 and 3 and we had to find a target value of 4. If we sort this array, we get 1, 2 and 3 and then we can have two pointers. So one pointer can be the left pointer, one pointer can be the right pointer, and then we can iterate them one by one, move the left pointer and move the right pointer and arrive at two values whose sum is equal to the target value. So now the space complexity for this, let's say that we sort the array in place. So the space complexity can be constant. The time complexity for sorting will be n log n, and after sorting we will iterate the left pointer and the right pointer, and the maximum number of iterations that we can do include by both left and right pointer will be the entire array. So this is just n. So the time complexity should be n log n. So we have improved on the time complexity, which is a very good thing. But can we do better? Yes, we can. So the best possible solution for this problem will be to use a hash map or a dictionary in Python. So what we can do is we can make a map. This can be a map from value to index. My handwriting is abysmal, and apologies in advance. Okay, so what we can do is, let us say that, let me take an example from LeetCode. We have this array 2, 7, 11, 15. So we have this array 2, 7, 11, 15 with index values 0, 1, 2, 3. We can create a mapping from value to index. So our map will be our values, which are 2, 7, 11, 15. And for every value, we will store the index. So the corresponding index is 0, 1, 2, and 3. Now we have our target value. So the target value that was given in over here was 9. We will iterate on our array one by one. So let us first arrive at 2. We are currently standing at 2. When we are standing at 2, what number do we need? What number are we looking for so that when we add that number to 2, we get 9? So that is the required number. That this number is required. This is the number that we need. If we have that number, we can add that number to 2 and we can get to 9. So the required number when we are at 2 will be 7. And we can easily think about the required number, if we are standing at any number a, will be the target number minus a. So if you're standing at 2, you need 7 because 7 plus 2 is equal to 9. If you're standing at 0, you need 9 because 9 plus 0 is equal to 9. If you're standing at minus 5, then you need 14 because 14 plus minus 5 is equal to 9. So depending on where you're standing, if where you're standing is a, the required number is target minus a, because target minus a plus a will be equal to the target. So if you can find this required number somewhere in the array, then problem is solved. Then we have our current number, we have our required number, we have both of their indices. We can just return them and that will be the answer. So the first number that we arrive is 2, and the required number, the number we are looking for, is 7. So you can just ask our map, like, hey map, does 7 exist in our array? So our map will be like, yes, it does exist. If it does exist, at what index does 7 exist? 7 exists at index number 1. So this is our answer. Our answer is index 0, where we are currently standing, 2, and index 1, where 7 is. Because when you add the elements at these indices, you get your target value 9. Okay, so this method does work. Can we prove it that this method will also work with duplicate values? I can prove that as well. So let us say that we have an array with duplicate values. So the values are 3, 2, and 5 and 2. And let us say that the target value that we are looking for is 4. The indices are 0, 1, 2, and 3. So we know that the answer should be 1, 3, because at index number 1 we have 2, at index number 3 we have 2. When you add 2 plus 2, you get target value 4. So the first thing that we do, we will create our map. So we will create a map by iterating on our array from left to right. We arrive at 3. 3 exists at index 0. Then we arrive at element number 2. 2 exists at index 1. Then we arrive at element number 5. 5 exists at index 2. Then we arrive at element number 2. So 2 is already there in the map. So we're updating the index. 2 now exists at index number 3. So you see that we have overwritten 2. We have overwritten the index 2. So now that we have created a map, we will now iterate on our array to search for the target value. So we'll start from the left. We are currently at 3. Our current value is 3. So the required value, what number do you need? We need 1. If we have 1, 3 plus 1 will be equal to 4. So does 1 exist in our map? 1 does not exist. Moving on. We are now standing at 2. What is the required value? Required value is 4 minus 2, 2. Does 2 exist in our map? We ask. Our map, does 2 exist? 2 does exist in our map. Because 2 exists in a map, we are currently standing at 2, and 2 also exists in a map. So now there are two possibilities. The two possibilities are that the index of 2 that we have received is our current index, or the index of 2 that we have received is some other index. If the index of 2 that we receive is our current index, this is not a solution, because it is clearly stated in LeetCode that you cannot use the same element twice. So if the index that we get from the map is our index where we are currently standing, this is not the solution, we move on. If the index that we receive from our map is some other index, it is not where we are currently standing, that means this is a valid solution, because these are two different elements. They may have the same value, but they're unique, two separate elements, and their sum is equal to the target value. So if the index that we get from the map is equal to current index, this is not the solution. If the index is some other index, this is the solution, and we will return this as a valid answer. Another thing that we can note is, it is possible that 2 exists multiple times in the array. So let us say that we have 2 over here, then 2 over here, 2 over here, 2. It's a very long array, and we have multiple number of 2s. So then the question arises, which pair should we return? Should we return index number 0 and 3, index number 0 and 4, index number 0 and 5? Which pair of indices should we use? The answer is, LeetCode clearly states that there will exist only one pair of valid solutions. So this case that multiple solutions might exist will never arise, and that has been promised to us by LeetCode. So we don't need to think about it. So yes, this will be the most optimized solution of approaching this problem. The space complexity for this will be big O of n, because we're creating a hash map, and the maximum number of entries that can be there in this hash map or dictionary can be the number of elements. If every element in our array that we're receiving in our function is unique, then there will be maximum n number of elements in the hash map. So this is the maximum space that can be occupied when we run our program. So the space complexity will be big O of n. The time complexity, on the other hand, first thing that we're doing is we're creating the hash map. So we're iterating once over every element of the array, and for every element of our array, we are updating the index. So when we iterate over every element, we're working for every n elements. And for every n elements, we are performing an updation operation on a hash map, which takes constant time. So the total time taken for creating the hash map will be n, because we're working once for every element in our array. After we have created our hash map, we will once again iterate on our array from left to right, searching for the required value. We will compute one required value for every element, and for every required value that we compute, we will perform one search operation in our hash map or in our dictionary. Does the required value exist? Computing the arithmetic required value for every element and computing whether that required value exists in our hash map or not is a constant operation. So once again, we're doing this for every n element. So the time complexity for this solution will be big O of n. So we have reduced the time complexity to linear time, which is excellent. Now let us see the solution. Let's see the code in Python. All right, I'll just reset to defaults, confirm. I'll copy this in a blank canvas. We have this list. I'll import this from typings. Okay. Now the first thing that we need to do is we need to create our mappings. Okay, so our mappings is basically a dictionary. We will iterate for every value in our array. So the array is called nums, and for every value we will update our mappings that this element exists at this index. So mappings for this value exists at this index. So the first thing that we have done is we have created a map from value to index. Now we will once again iterate on our array and see whether a corresponding value exists in our array such that the sum is equal to target. So we will once again iterate for every index and value. For those of you who do not know, enumerate is a special function in Python which returns an iterable object which gives you both the index and the value of that iterable. So if I would have directly iterated over numbers, which is an array, I would have only received the values. But as I want both the index and the value of that number, I'm using the enumerate function. So enumerate function is used very frequently in Python to receive both the indices and the values. So now for every value, I will compute the required value. So the required value will be target minus value. So this is the value that I need to exist in my array. If this value exists, then I can add the value and required value and obtain target. I will check if my required value is present in mappings, and if this is present, the index at which this required value is present should not be equal to the index where I am currently standing. So the index where this required value exists should not equal my current index. If this case is true, if this value is present in my array and the index at which this value is present does not equal my index, I found the answer. I can simply say that the answer is my current index where I'm currently standing and the index where this required value is present. If this is not the case, if this required value is not present in mapping, or if this is present in mapping but this is present at the same index where I'm currently standing, then do nothing. We have not found the answer, just move on to the next value, and yeah, just keep on searching. And that's it. We have solved the problem. So let's see whether we have whether this is the correct solution or not. I'll revert. Let's run our code. Okay, it's accepted. So let's use sample test cases. So now I'm going to use all the sample test cases 1 to 3 that were present here in the problem, and I'm going to run my code and see. So this gives me some confidence that maybe this is correct. This has been accepted. So let me just submit, and if this passes all the test cases, that means that the solution is correct, and it should be correct because we have proven this mathematically. So this is the solution for 2sum in Python: space complexity big O of n, time complexity big O of n. Thank you very much. If you have any other solution or other approach to this problem, please leave it down in the comment section below. I would love to see what people can think differently. I would love to see what approach you take. Thank you very much. See you in the next one. Ciao.